Okay, so this is part 2 of it, and then I'll try to get into the homework. I'll try not to make this very long. So from this point, you're going to take the x squared plus 6x plus 9, and you're going to factor that into x plus 3 times x plus 3. You could use Xbox for that, and that's how I got that. Okay, so now you're left up with all these factors: 2x, x minus 1, x plus 1, x plus 3, x plus 3. You can see that we have roots here. For 2x, the way to make that 0, you would just set x equals 0. X minus 1, to get that to be 0, you would need x to be 1. For x plus 1 to equal 0, you'd need negative 1. For either one of these x plus 3's, you'd want this negative 3. So you can see it on here how that would look. Alright, so on Wolfram Alpha, you can take a look and see it, that if I plug this in, I actually get this graph. And you can see all the zeros here. See how it shows you the solutions? Your solutions are negative 3, negative 1, 0, and 1, just like we predicted. Okay, and if we factored it correctly, see how I factored it exactly as we did it? So it should be correct. And if we look at our...
Hello, SPHS.
Okay, so you have a multiplicity of 2 for the root negative 3. Right? And that's all you need to say. The other part of this is the rational root theorem. So I'm going to clear this off, and I want to bring up the textbook here. Okay, so when we look at the textbook, they give you a complicated thing to look at, and it's kind of hard if it's the first time you've seen it. So essentially what it is the rational root theorem is a way that we can kind of save time in knowing what factors we might have. Okay, so if we know what factors we might have, it makes our life a lot easier. Okay, so it's always broken down like this. So for example, the previous problem that we have, and I'll write it back up. Okay, so I wrote it back up, and this is what I did. I took the x out, and that's going to help us a lot. So essentially what the rational roots theorem, or the rational roots theorem says is this. I'm going to pull it up right here. The rational root theorem. If the polynomial p of x has integer coefficients, then every rational root of the polynomial equation, and by rational root, that's anything that is like a 3 over 2 or a 1 over 2. Anything that can be put as a fraction. So that would be whole numbers and fractions. Integer coefficients, those are whole numbers: 1, 2, 3, 4, negative 1, negative 2, on and on. Okay. So if the polynomial has integer coefficients, then every rational root of the polynomial equation p of x equals 0. So in other words, every 0 that we can find can be written in the form of p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. So in other words, p is the factors of sorry, I have to move from location to location. So we have p, which is any of the factors of the constant term. So p is for the constant term, and that could be plus or minus 1 and plus or minus 18. It's always going to be plus or minus because you have your choices of multiplying 1 times negative 18 or negative 1 times positive 18. Then you have plus or minus 2 and 9, plus or minus 2, plus or minus 9. You also have possibilities of 3 and 6. Okay, so those are your factors of your constant term, and that's what p is. Whereas q are your factors of the leading coefficient, and that tells me that I have plus or minus 1 and plus or minus 2. Those are my only factors. Now, what the rational roots theorem tells us is that we have two options here. Is that we have, it doesn't tell us that we have two options, I'm sorry. It says that any root we have is always going to be p over q. For example, what was one of the roots that we got? One of the roots we got was 1 and -1, right? So we can even check that's one of them. If we want to check to see that it would work, and this is kind of like how I started to guess what we want to start with, I just said, okay, I'm looking at P, and I'll take a positive one, and I'll take a Q, which is also a positive one, and I would have checked 1 over 1, right? And that was one of the roots that worked for us. So you essentially take each root and you try it as a synthetic division, right? So you take 1 here and you say 1, then you go ahead and follow through on the synthetic division. Okay. From there you can do the rational roots theorem again. I'm gonna have you guys attempt to kind of try to do one of these, as far as you want to try to pick one of these out, like either use this and this one, or this and this one, etc. And those are the ones that tell you that you have a root there. Your root has to be some form of P over Q. In other words, it could be 1 over 1 or 1 over 2 or 18 over 1 or 18 over 2 or 18 over -2 or -18 over -2. So any list of these combinations is going to work. So essentially what it is it narrows down your guessing choices, which kind of helps, but it kind of doesn't help too much. Essentially it narrows down your choices, and instead of just guessing arbitrarily, you have something to start with to guess. So the rational root theorem gives us an opportunity to kind of save time. Okay, so let me tell you what your homework is going to be, and I'll put this right here at the end so you guys have seen it. So let's see, we've covered multiplicity and we've touched on the rational roots theorem. That's a hard one, and I think I want to be in class to show you guys more, but if you could try to understand it as much as possible by reading the book and just kind of looking over what I said about it. So essentially I'll give you what it looks like. So in this example it says that we have something like this: x to the 3rd power plus 3x squared minus 10x minus 24. By the rational roots theorem we can identify the possible roots. So for all my p's, which would be the constant right here, -24, here are my possible roots: 1 and 24, 2 and 12, 3 and 8, 4 and 6, right? And then I also have my q, but my q is my leading coefficient, which is 1. So all my options here are 24 over 1, or 12 over 1, 8 over 1, 6 over 1, 4 over 1, 3 over 1, 2 over 1, or 1 over 1. So those are all my possible things. Okay, and what they did here is they actually plugged, they took all the possible roots, 1, 2, 3, 4, which would be all of these, and then they went ahead and did synthetic substitution into it. So this is actually the synthetic substitution. They put 1, 3, -10, -24. Those are the numbers they put inside the box, and then they did the actual thing here to see which one's the rational root. So here's the rational root. The actual root is 0. So if you plug in 3, that's the one you want. Okay. Alright, let me just show you what the homework would be, and then I will end this video. Okay, so why don't I have you guys do 2 to 7, and also with that one you need to tell me what multiplicity your roots are. So from 2 to 7, just here, and tell me what your multiplicity is. So you should be able to group or kind of factor out using synthetic division, or you can use long division and kind of guessing. If it helps, I would suggest you use Desmos. Type this in and it'll kind of give you one of the roots, or look for one of the roots, just look at the 0 and then plug it in. So come back to class with a lot of questions. We should be, this is the harder part, so we're going to take another day on this, but this should be the harder part, and then we'll quiz again on this part, because this is the hardest section in my view. Okay, alright, thanks.